Hello everyone, today we'll be discussing factors affecting basicity and acidity. So before we proceed, we are going to define some important terms. The first term we have is basicity. Basicity is defined as the ability of a compound to accept proton or donate electron pair. So in this context, acidity is defined as the ability of a compound to give out proton or to accept electron pair from electron donor molecules. One of the important factors that affects basicity and acidity is resonance. By definition, resonance is defined as the delocalization of pi electrons or pi bonds in a molecule without changing the position of the atoms in the molecule and breaking up octet rule. In other hands, in resonance, what we have is delocalization of pi bonds. The sigma bond or the single bond are not broken, but rather we observe the change or movement or delocalization of the pi bonds or pi electron in a molecule without actually breaking the octet rule. For basicity, resonance affects basicity. Presence of resonance decreases basicity. This can be observed using these two molecules, the cyclohexylamine and the aminobenzene. The cyclohexylamine here, we do not observe resonance. So because of that, the lone pair on nitrogen atom is concentrated on the nitrogen atom. But in the aminobenzene, the lone pair on the nitrogen atom is not concentrated on nitrogen atom. Rather, it is delocalized around the ring system. So because of that reason, the cyclohexylamine is more basic than the aminobenzene. The reason attributed to this basicity of cyclohexylamine compared to that of aminobenzene is that we observe resonance in aminobenzene, but in cyclohexylamine, we do not observe resonance. Therefore, cyclohexylamine is more basic than aminobenzene because of resonance. For acidity, resonance increases acidity. This can be observed using these two compounds, phenol and cyclohexanol. In phenol, we observe resonance, but in cyclohexanol, there is no resonance. Phenol is more acidic than cyclohexanol because the phenoxide ion is resonance stabilized, while the oxygen charge in the cyclohexanol is not resonance stabilized. So resonance accounts for the major difference. The resonance accounts for the major reason why phenol is more acidic than cyclohexanol. Another important factor to consider is the electron withdrawing group. Electron withdrawing group, having an electron withdrawing group substituent decreases basicity. This accounts for the major difference in basicity between ethylamine and ethanamide. Ethanamide contains an electron withdrawing group, which is the carbonyl functionality. The carbonyl functionality is the electron withdrawing group attached to the amine. The two things this compound has in common is the amino functionality, which is the NH2. In the ethylamine has electron donating group, which is the alkyl group, but the ethanamide has an electron withdrawing group, which is the carbonyl group. Having an electron withdrawing group decreases basicity, and while having an electron donating group increases basicity. In terms of acidity, having an electron withdrawing group increases acidity, while having an electron donating group decreases the acidity. This can be illustrated using these two compounds. The first compound on my left hand side contains chlorine, which is an electron withdrawing group, while the other one does not contain chlorine. Therefore, the structure which contains the electron withdrawing group chlorine, it tends to be more acidic than the structure which does not contain an electron withdrawing group. So generally, in terms of electron withdrawing and electron donating group. Having an electron donating group in a substituent increases basicity, and having electron withdrawing group in a substituent increases acidity. In terms of electron donating group, diethylamine is more basic than ethylamine, and ethylamine is more basic than methylamine. The reason is attributed to having a more electron donating group. In the diethylamine has two alkyl group that pushes electron to the nitrogen, enriching the electron density in nitrogen atom. In ethylamine, we only have the ethyl group that pushes the electron to the nitrogen atom. And last, in methylamine, we just only have the methyl group that pushes electron to the nitrogen atom. Therefore, in terms of basicity, having more electron donating group in a molecule tends to increase its basicity. So this is the reason why diethylamine is more basic than ethylamine, and ethylamine is more basic than methylamine. In terms of acidity, having an electron donating group decreases acidity. This can be observed between in these three compounds. Ethanoic acid is considered to be the most acidic in comparison among these three compounds, because ethanoic acid has the least electron donating group, which is the methyl group attached to the carboxylic functionality. The least is regarded as the one that has two alkyl groups that is attached to the carboxylic acid. Generally, factors B and C are referred to as inductive effect. In terms of hybridization, as you move from sp3 hybridized to sp2 hybridized and down to sp hybridized, the S character increases. As the S character increases, the basicity of a molecule decreases. While in acidity, as the S character decreases in acidity, here now we can observe that ethane is most acidic, whereas the ethane is the least in acidity. sp hybridized orbitals are closer to the nucleus than sp2 and sp3 hybridized molecule. The reason that accounts for this hybridization, why the sp character increases acidity, whereas if you observe sp hybridized character in a molecule, it decreases the basicity. So for that reason, if you have a negative charge, for example, this negative charge attached to the carbon compound in ethyne is more stabilized than the negative charge observed in sp2 hybridized. This is not far-fetched. This negative charge in sp hybridized molecule is closer to the nucleus, and the nucleus is positively charged, whereas since this sp hybridized molecule is closer to the nucleus and the nucleus is positively charged, this ion tends to be more stabilized than the ion in the sp2 hybridized molecule, while the ion in sp3 hybridized molecule is the least stabilized. Reason is attributed to this hybridization and the closeness of the sp hybridized molecule to the nucleus. Another important factor that affects basicity and acidity is electronegativity. This is a property of non-metal that increases across the period. So from here, fluorine is more electronegative than oxygen, and oxygen is more electronegative than nitrogen, while nitrogen is more electronegative than carbon. Important factor we have to explain here is negative charge is more stabilized on more electronegative atom. That is, when you have a negative charge on more electronegative atom, the molecule tends to be more stabilized when you have a negative charge on less electronegative atom. Let us consider these pairs of molecules A and B and C and D. When you compare and contrast between A and B, you will observe that In A, the negative charge is on less electronegative atom, which is carbon. And in B, the negative charge is on more electronegative element, which is oxygen. So having the negative charge on a more electronegative element, which is B, will be more stabilized. And when the negative charge is more stabilized, it means that the compound will be more acidic and less basic. So from A and B, we can conclude that A is less stabilized while B is more stabilized. Therefore, A is more basic while B is more acidic, and A is also less acidic, whereas B is less basic. If you compare and contrast between C and D, you will notice that in molecule C, the negative charge is less stabilized because nitrogen is less electronegative than oxygen. So because the negative charge is on less electronegative element in C, we can conclude that C will be less acidic, whereas that of D, where the negative charge is more stabilized, will be more acidic. So generally, if a negative charge is more stabilized, it means that that negative charge will be more acidic and less basic, and vice versa. Thank you so much. If you enjoy watching my video, please like, subscribe, and share. Then if you have any question, any correction, any contribution that can make this video better, please, you can drop it in the comment section. Thank you, and see you next time.